Today we're going to talk a little bit more about limits at infinity. This is section 3.5 in the Larsen book. When we have some basic rational functions, the important thing to remember is that the highest exponent is all that matters in the numerator and denominator. The only thing I would caution you about is to see the order that the terms are written in. So here, terms are out of order. The highest exponent in the numerator is the 5x cubed term. The highest exponent in the denominator is the negative 2x to the fourth term. I can ignore everything else because as I'm approaching infinity, the biggest exponent, the highest exponent, is what's going to take precedence over everything else. Now I'm going to just simplify this. This x cubed cancels and I end up with an x. So really, what this problem becomes is the limit as x approaches infinity of 5 over negative 2x. This was our basic theorem, or our basic understanding. If I have 5 over a negative big number, negative 100, negative 1,000, negative 10,000, that's going to equal 0. Very similarly, we do the same thing with negative exponents. So here's another problem. This time it's written in a nice order, in descending order of the exponents. I've got the 2x to the fifth in the numerator, the x to the fourth in the denominator. Those are the highest exponents. Everything else I can ignore. This simplifies a little bit differently. The x to the fourths cancel, and I'm left with the limit as x approaches negative infinity of 2x. 2 times a really big negative number is just going to approach negative infinity. Think about what's going on. Try out some numbers. 2 times negative 100, negative 1,000, negative 10,000. What this means is the function decreases without bounds. Here, the function levels off at y equals 0, so we have a horizontal asymptote. Not in this case. This is a problem that I think should be simple, but a lot of times people make it too hard. The 8 does not have a variable with it. So I'm only concerned about this term. If I take the limit as x approaches infinity of 1 over x, this limit goes to 0. So my final answer there is 8, which again would be a horizontal asymptote at y equals 8. In this problem, we're going to go back to what we do with the limit of a composition of a function, which, recall, we move the limit inside. So this really is 5 cosine the limit as x approaches infinity of 3 over 2x. Once again, if I take this limit is going to go to 0. So then I'm just going to evaluate 5 cosine of this limit, which is 0, because 3 over a big number is going to take us to 0. The cosine of 0 is 1. 5 times 1 is 5. That's my final limit. Finally, we're going to look at what the definition of the square root of x squared is and look at a couple of those problems. So let's think about what's going on when we take the square root. When we take the square root, it's always the principal square root, which means the positive square root. So for example, if I take the square root of 100, I just say 10. So let's look at what's going on here. The square root of x squared is x if x is positive, greater than or equal to 0. So let's look at an example. Let's say x is positive 7. That means x squared clearly is 49, and the square root of 49 is 7, which is the same value of x I started off with. So nothing actually changes. Now, let's say instead I started with x equals -7. Well, x squared is still positive 49, and the square root of 49 is still 7, but I can see that it's the opposite of what I started off with. So the square root of 49 is still 7. Since I started out with x equals -7, my answer is the opposite of that, which we denote by the minus out in front, or the negative sign. So if I'm going to use that in the limit problem, once again, I take the highest exponent in the numerator and the denominator. So in this case, the 3x and the 2 over the square root of x squared. Since I'm approaching positive infinity, I use the top part of my definition. X is a positive number. So the square root of x squared is just x. So this becomes the limit as x approaches infinity of 3x over 2x, which is just 3 over 2, which again would be a horizontal asymptote at y equals 3 over 2. The bottom case is slightly different. The only thing that's different is we're approaching negative infinity. So once again, I do not worry about the 7 or the -1. I'm looking at the 3x and the 2 square root of x squared. So I'm going to rewrite limit as x approaches negative infinity of 3x over 2. Because I'm approaching negative infinity, I'm using negative numbers. So I'm going to come to this definition of the square root of x squared. This is going to be 2 times -x. When I simplify this, I get -3 over 2. Still, I have a horizontal asymptote at -3 over 2, but the reason we have a negative here goes back to the definition. And that's the main idea about limits at infinity.